Welcome back. So, since the increase of photogeology, wide range of electromagnetic spectrum was used to produce the satellite data. New scanners or sensors were used, of which the multispectral scanner was used extensively. But nowadays we are having hyperspectral scanners also, which will have lot many different bands, okay, not only restricted to 7, but you will have more spectral bands. Okay. So, I will just browse through very quickly the Earth's resource technology which came in, okay, and which was launched in 1972. So, we have a complete range of the launches which have been taken which took place in last few couple of decades, so that you can refer in. So, these are the timeline of artificial satellites and space probes, which started from 1957, which goes here. Okay. So, mostly you will find that many developed countries they launched, okay, but India also came into the picture, and that also you can look at that. Now we are having almost like around 100 satellites which are in the orbit. So, this is just for your reference information which you can look at. So, if you take in terms of the Indian part, India has launched almost like 101 Indian satellites as on 2nd September 2017 of many types since its first attempt in 1975. Okay. So, since then we are having almost 101 satellites thus for various applications has been given here. Okay. So, in 2017 lot many satellites were being launched, and one which will make 102, that is Cartosat, it is still to be announced actually. Now, as we were talking about the multispectral scanner or the multispectral data, so it is a scanning device which has a capability to scan the terrain to produce different synchronous images, each at different wavebands. So, different wavebands have different wavelengths. So, for example, we are talking about 1 to 7, which we saw in the slide of the spectral reflectance curves, okay, where we were talking about that how the water will be absorbed and where in under which range the water will get absorbed, or we will be able to see the reflectance and vegetation and, for example, soils also. Okay. So, different wavebands have different wavelengths. So, depending on the application and purpose, for example, you can pick up different bands. Now, band 4, which is green, band 5 is red, band 6 infrared to lower infrared, and band 7 is infrared, and they have their respective wavelength ranges here, 0.5 to 0.6 for band 4, 0.6 to 0.7 for band 5, 0.7 to 0.8 band 6, 0.9 to 1.1 for band 7. So, if you look at the application, the band 4 is excellent for identification of different depths and or turbidity of the water along the coastal areas. Okay. So, if you are exclusively looking for the coastal zones and all that mapping in that area, you can straight away use band 4. For band 5, for topographic features and vegetal covers, okay, you should use band 5. Okay. And band 6 gives good tonal variation, which is used for land use pattern drainage studies, soil, etc. And then band 7, good for differentiating land and water, best for hydrological studies. Therefore, for geological investigation, multispectral data, if you want, band 5 and band 6 are most suitable. So, band 5 and band 6, this both are the most suitable one, since it gives good information about geology, geomorphology and regional geological structures, soil variation, etc. Now, bands designated for Landsat satellites mainly. So, you have multispectral scanner. So, you have from band 4 to band 7, band 1 to band 4 for Landsat 1 to 3. So, we have multiple like several Landsat satellites. Okay. This again I will not get into the details of this, but you can read out, it is again important. So, if you look at the thematic mappers Landsat, then you have the range which is starting from 1 to 7. So, this TM images consist of 7 bands with subsolution of almost 30 meters for band 1 to 5 and 7. So, ETM, enhanced thematic mapper, which again will have almost like 8 bands, and this was Landsat 7. So, these are some of the important things which have been given, but anyways we will not be using this in our course, but you can have for your reference. Now, this is satellite photo, high resolution satellite photo, panchromatic data, corona. This is a corona satellite photograph of Indo-Gangetic plain, which shows the darker colors here could be related to the water bodies, and you have the complete range of gray shades which are available here, which can help you in identifying the different features. Okay. So, these are some of the cutoff channels here. We are having like what we call the oxbow lakes, and then this is your main channel. At the same time, on the periphery of this one, you can see migration of different channels, and of course one can also mark which needs to have the ground conformation or ground truthing, the older terraces or higher terraces or lower terraces also here. Now, coming to the remote sensing part here, if you look at, or we can talk about the why it is important, or the photogeology part deals with the identification of geological features, landforms through study of aerial photos and satellite data. Okay. So, satellite data may be in form of color images or black and white. Usage of photo interpretation was extensive during Second World War. Aim is to identify various geological structure, major landforms, that is what we call the geomorphology, and stratigraphic contacts. So, basic use of photo interpretations, land use, site selection for construction of any civil structures, urban design, agricultural practices, transportation network, environmental degradation, and for military purposes. So, in general, we are looking at the aspect, because the photogeology is part of the remote sensing only, the complete technique, and which can be used for several purposes. Okay. So, remote sensing data has many applications. Okay. Mapping land use and cover, agricultural soil mapping, city planning, archaeological investigations, military observations, geological and geomorphological surveying. Advantages and disadvantages of aerial photos. Advantages: time. If you use the aerial photographs, and in particularly if you are using the high resolution satellite data, either it is aerial photograph or satellite images or satellite photographs, okay, the time which you will consume in mapping the area will be drastically reduced, because you need not to go in the field and all that. Okay. And why photographs are very good or important? Because they will give you a very high resolution information as compared to the satellite imageries. Okay. So, where you will have, for example, 30 meter of resolution, absolute resolution, here you will may have a resolution of 1 meter or even less. Okay. So, depending on that at what height you have flown. Okay. Then of course, the money part, because more when you fly for collecting the information for any area, okay, that information can be passed on to multiple user. Okay. So, once the investment is done, the same data can be used by different users. Okay. So, for example, we were talking about, again you can have the information you would like to extract from this. Okay. Accuracy will be very high when we are talking about the ortho photographs or vertical photographs which have been taken by the aircrafts. Okay. Data form, either you have the data which is available in digital form, which can be passed on to many users, multiple users, and it is easy to use those or for the interpretations. Disadvantages we have in terms of the scale, because the flight will not stay at the same height every time because of several reasons, either it is turbulence or maybe another reasons. It will have some issues related to the tilt and all that. Okay. Either the camera got tilted or the flying height was varying from while passing through the terrain. So, scale is one of the disadvantage in the aerial photographs. Okay. Only large features can be marked. Exact identification of rock is difficult sometime. Okay. I would say that it is sometime, but if you take of course and very high resolution photographs, then you will be able to also mark the smaller features also. Okay. Exact identification is difficult because the photographs will not, you will not be able to remove the vegetation and all that. So, you may have a disadvantage when you are having a very thick cover of vegetation. Only surface features can be identified, you cannot go to the deeper part as in terms of other satellite informations or the data which is available. So, these are the advantages and disadvantages which we have. Okay. But most of the portion, if you look at, we have good amount of advantage using aerial photographs. These are just to show the two photographs of the same area in color and black and white, or we can say in the shade of the gray color. Okay. Importance of photo interpretation in civil engineering mainly. So, engineer should have in-depth knowledge of terrain on which the engineering structure is to be built. Okay. Photo interpretation provides information regarding rocks, drainage, availability of construction materials, slope stability, etc. This helps in selection of suitable sites. Okay. Therefore, the information which we are going to generate or extract from the satellite data or the satellite photos will play an important role in any urban development. So, we were discussing about that how it is how important it is to catalog the photographs, to identify the line of light. Okay. Now, further, these are the few things which are important in terms of the photograph which has been collected, either it is vertical or oblique, but mostly this parameters which we are talking about, the principal point, then why it is important for us to know the focal length, and then the height of the camera, and what is nadir point and all that. Okay. So, this sketch, it shows that in terms of if you are taking the area which has been covered by the photograph. Okay. So, this plane here is your the photograph, and the point A and B, for example, these are the two objects here on the photograph are represented here on the ground actually. Okay. So, this all information is important when we will be talking about more in detail in terms of the parallax, differential parallax, or we are talking about the scale of the photograph, how to calculate the scale of the photograph. So, let us get acquainted with few of the terminologies here. We already talked about the fiducial marks and the principal point and the conjugate principal point. They are extremely important to identify the line of light and all that. Okay. So, terms which we are using, conjugate principal point we have already discussed, but we come down to the nadir point. Okay. So, nadir point is a point at which a vertical line through the prospective center of the camera lens pierces the plane of the aerial photograph, or you can say the point vertically beneath the camera at the time of the photograph taken. Okay. So, you have this is the exactly vertical on the prospective center of the camera. So, you have that is your nadir point. And then you have another isocenter. Okay. So, principal point, if you are having vertical photograph, exactly vertical photograph, then the principal point and nadir point will be the same. But if you are having slightly oblique, then you will have the principal point will be different and the nadir point will be different. Okay. So, this is what we see. Okay. So, we have the nadir point will be exactly vertical, but this will be perpendicular to that. Okay. So, you have principal point and the nadir point. Okay. And the center of this two will be termed as isocenter. So, definition of the photographs, if you take vertical photographs, this we have already talked about. Okay. A focal length, the distance from the front nodal point to the plane of the photograph, okay, from near nodal point to image plane, this is termed as focal length. This is also important because when we are trying to calculate the scale of the photograph, this will play an important role. Then we are having exposure, station, position of the frontal nodal point at the instant of exposure. Then you are having flying height, which is again important, the elevation of the exposure station, that is the camera lens above sea level or above mean sea level, or any selected datum. Okay. So, for example, you are having this is the datum here and you are having a ground level which is not flat, it is undulating. So, you will have the variation here, okay, in terms of the height, and this is your focal length of the camera, and this is your height. So, on vertical aerial photograph, the scale is expressed as S equal to F, that is your focal length by height, that is a flying height here. So, example, if you are having the focal length is around 6 inches and height is around almost like 15,000, and the scale which will be given will be in terms of the representative fraction or ratio fraction, okay, that is RF. Now, if you take this, I have slightly simplified it. So, you are having the camera lens here, okay, and this is the plane of film, and this are the 2 points which are also on, these are on the photograph and these are on the ground here, okay, and this is your terrain. So, you are having datum plane at mean sea level, for example, you take, or any reference plane you take, with respect to that you are having the terrain here. So, here we are showing that the terrain is almost flat, which is above mean sea level. So, if you are taken the datum as mean sea level, then this is above mean sea level. So, you have F here, you have H, and that is your datum from the point of the lens, and this is your the difference between the datum and the terrain elevation, okay, and this one is your small h, that is above mean sea level, that is the height of the terrain or any location. So, you are having L is your lens. So, representative fraction or fraction ratio fraction scale is expressed as we have discussed here. So, if you are having this information, you can talk about, okay. So, capital H minus small h, that is your height here, and you are having the elevation of your that, where F is the focal length of the camera, H is the camera above mean sea level, and small h is the elevation of the terrain above mean sea level. So, for example, if you are having the focal length is 152.4 millimeter and height, okay, that is an altitude of the aircraft is around 5,000 feet and 2,000 feet is the elevation of the object. So, you can have a scale like this, these are in feet, and finally, you can refer this ratio fraction as 1:9,600. So, this means 1 unit of horizontal distance on photograph is equal to x number of same units on ground, that is 1 mm on photograph is equal to 9,600 mm on ground. So, you can calculate the scale based on this if you are having almost vertical photograph. Further, you can have different representations also in terms of the scale or the photo scale. So, representative fraction, the ratio of the distance on a photograph to the same distance on the ground, and is expressed as a simpler fraction as we were talking about in the previous slide, as it is 1:, for example, 15,840. Okay. So, what we are looking at, the photo distance and the ground distance we are taking. Okay. So, whatever has been measured on the photograph, it will be reflected same on the, or it is the ground, but depend on the ratio what we are taking here. So, it is usually referred as either, for example, 1:24,000 or so. Okay. So, this we will continue in the next lecture using the topographic maps and all that. Okay. But before that, we will have more in few of the labs in which we will discuss more on the how to calculate the height and the distance and all that. Thank you so much.